Here's another part for you. Sometimes, for the series, it might be easier to show absolute convergence. Here's what that means. Say we have a series of A sub n. Okay, it may have that alternating. Usually when we're thinking absolute convergence, we're thinking with an alternating series one, but I don't guess it necessarily has to. But a series of the A sub n's is said to be absolutely convergent if the series of the absolute values of this A sub n's is convergent. Here's an example of that, how that would work. Series is said to be absolutely convergent if, makes sense, right? If we do the absolute values of the series terms, and those converge, then we know the series is absolutely convergent. And if it's absolutely convergent, then we can say it's convergent in all the terms that we've been talking about. Here's a good example of that. Let's say we were talking the series of negative 1 to the n over n squared. That series right there. Well, if I look at absolute convergence there, do you see that? Let's check absolute convergence here. So that means take the absolute value of all the terms. Well, if I take the absolute value, what does that take out? The alternating series. Yeah, it's just 1 over n squared now, isn't it? Because everything turns positive. The n squareds, of course, are already positive. So isn't this equal to just 1 over n squared? And this is a nice series because what about that? That is convergent. Why? Because it's a p series. P equals 2. Yeah, anything with a p series greater than p greater than 1 is convergent. So this converges, therefore this absolute value thing converges, so that means this series is absolutely convergent. So no need to go into any other tests for that. You don't have to use alternating series test here for this because it's absolutely convergent. If it's absolutely convergent, it's definitely convergent. Absolutely convergent is a stronger term than convergent. Just saying it's convergent. If it's absolutely convergent, that's saying something stronger than convergent. So it's good to know if it is. Now, let's go back to a similar one here. Doesn't always work, though. Is this series absolutely convergent? Well, if I look at the absolute convergence of that, I wind up with what? Harmonic, okay, which is divergent. So is that series absolutely convergent? No. So that series is not absolutely convergent. Now, what we looked at, well, we looked at a slightly different version of it, but didn't we prove that this was convergent? I think we did -1 to the n minus 1, but that really wouldn't matter. This is the same thing. I think it's just the alternating signs would be shifted. But so basically we did prove that that was convergent. So you see there is sometimes a difference between absolutely convergent and just convergent. This one is convergent, it's just not absolutely convergent. Sometimes that's referred to so it is said to be conditionally convergent. So if you see that term, that's what that means. Conditionally convergent means, yes, it does converge, just the absolute values don't converge of that same series.